Let's implement bubble sort in 10 minutes or less. And we'll do so in TypeScript. So we will export our function, just define it as bubble sort, and I will define it as a generic. So let's take in an array, and we'll annotate it to be an array of type T. So it's going to accommodate different data types rather than just being a number or just for strings. We want this function to be able to execute for different data types. So let's see, first we want to implement our unit test. So we can follow a test-driven development approach where we write a failing test, write the code necessary to make that test pass, and then potentially refactor. So first, we can utilize vtest. So I'll import the functions that we need. So we need describe, and we need it from the vtest library. So this allows us to write unit tests. So describe is where we will specify the name of our test suite. So I'll just call it sorting functions. And then we would define a callback utilizing the arrow syntax from ES6 JavaScript. And here we can define a test case. So I can say bubble sort should sort in ascending order. Once again, we define our callback function. This is where we define our arrange, act, and assert part of our test. So I'll just implement or initialize numbers array, and I'll set it in descending order. Right, and then we can utilize our bubble sort function. It's imported from the sorting class file we will implement shortly. I'll specify numbers as the data type and pass that in. Now we write our assertion. So I'll say expect numbers to equal, and I will write the expected output. Right, so import expect. So this is our test, and we will use that to test whether we successfully implemented bubble sort. So first I'll just do npm run test, and I should see a failing test. Good, so it failed. I'll close that out, close the console, and I have it defined in package.json, a script that runs vtest. Okay, so now let's implement bubble sort. So first I want to keep track if we have performed a swap. And this is a Boolean data type. Now the reason why we implement this or have this Boolean flag is this allows us to terminate the execution of the bubble sort prematurely in the case when the array is already sorted. So now implement the outer for loop. So for let I 0, I less than the array.length, and then I increments. So this outer for loop ensures that we iterate through every single element of the array at least once, and within each iteration is when we will loop through and perform the necessary swaps. So the largest values will bubble up towards the right. So here I will assign the value of a has swap to false, because we have not performed any swaps yet. And now we have our inner for loop. So I'll say for let j equal to 1. And I set it equal to 1 because we will be comparing the value at this index to the value just preceding it. And that comparison, we utilize that comparison to perform the necessary swap. And we'll set j is less than the array.length, making sure that we iterate through every element of the array, do the comparisons and the necessary swaps, then j increments. So now we want to implement a conditional to compare the values. So we'll say array at j minus 1, right, the value before it. Well, if that value is greater than the one that comes after it, then in that case, we will need to perform a swap. So in this case, I'll say has swapped is equal to true. And then I need to perform that swap. So in JavaScript, there's different ways to do this. I'll do it the longer way just so it is more applicable to other programming languages other than just JavaScript. So the same functionality can be used in Java or C#. So I'll say a temp value so we can store the previous value and not lose it. I'll set that to the array of j minus 1, right, the value that is larger in this case. Then I need to reset this value because I'm the actual swap operation. And then the array at j is assigned the value of temp. Right? I'll add a spacer just so it's a bit more readable. So this is the functionality of our bubble sort. The outer function means that we iterate through every single element of the array. In each iteration, the largest value will be put into its correct position at the end. And this inner for loop is done to perform the comparisons necessary for each iteration and perform the necessary swaps. Now, in order to make this more efficient, in the case when an array is already sorted and not have to perform unnecessary comparisons, we can check, okay, if we have not swapped, then that means that there hasn't been any value in incorrect position. So in that case, we can just return and stop the execution prematurely. So I'll talk about the time complexity. So the time complexity for bubble sort on average, for the average case, is big O of n squared because we have two nested for loops. That is one tell and one heuristic you can use when implementing algorithms. Is if you see two nested for loops, the outer for loop and the inner for loop, this performing the iteration n times and this one n times as well, n being the length of the array, then we know it's big O of n squared. Because we are utilizing the has swapped Boolean flag that we implemented here, so that for the average case, then it's actually big O of n for the best case scenario, in the case when we were given an array that's already sorted. Now the space complexity, meaning the amount of memory we need to allocate for this algorithm, is big O of 1 because we are not pushing anything onto the stack and we are not allocating any auxiliary data structure, as you're going to see in the future sorting algorithms that we implement. So we've implemented this one, we've implemented our test, and so now let's run our test and make sure everything passes. I'll do npm run test, and everything passes and we have successfully implemented bubble sort.